Oh, see, Riley's back already. Here we go. So there is a lot of what we've got in math is designed to build upon each other. That's the whole point of. Oh, did I not put one on your desk? I thought I did. I'll grab you one. Yeah, I'm definitely going to take more copies. Here we go. Ethan, have a seat.
I'll be just a second.
You're just real quick second?
Quick.
Real quick second. Get your bagel and have a seat. Okay, so I'm just going to do a real quick recap of where some of the mathematical operations we've used in the past have come from. So, math starts with addition. Y'all learn to add at some point. And then for some reason, we start adding the same thing again and again and again. Denny, headphones away, please.
Yeah, Denny.
Harsh and Hassan. As we're adding and subtracting things, we start realizing that there are ways to shortcut certain kinds of addition. We see this, I got 2 plus 2 plus 2 plus 2. 2 plus 2 plus 2 plus 2 equals 8. And rather than adding together long strings of the same number again and again and again, we develop a way to shortcut this. What is the way to shortcut this? Yes, multiplication. What are we going to multiply together? Or what is the multiplication statement going to look like from this? It's going to be 2 times 4. Or 4 times 2. I'm going to write it as 4 times 2. Because it's an easy way to read it, left to right. We are multiplying 4 2s. Or sorry, I'm repeatedly adding. I shouldn't say it that way. Scratch what I just said. We're repeatedly adding 2s. We're adding 4 2s. So we have 4 of the thing that we're adding to itself. That is where multiplication came from. Multiplication is just repeated addition. It's like, okay, well, 4 times 2 is 8. I have 4 2s being added together. That's why we developed multiplication. Now, the same thing is true for repeated multiplication. If for whatever reason I'm multiplying the same thing together a bunch of times, this is where we developed this power notation. So this object right here is called a power. It is made up of 2 parts. For those of you who have never seen this before, it's made up of a base and an exponent. The base is the big number right here. And just like what I did up here, the base is the thing that is getting repeated, except now we're not repeatedly adding, we're repeatedly multiplying. Mul is being the number that is repeatedly multiplied. And just like up here when we were repeatedly adding, I had a number out front that I multiplied to tell me how many times I was repeatedly adding the 2. This exponent right here, that number that's raised, is the number that we use to tell us how many times we multiply the base by itself. We call that thing the exponent. It's how many times the base is multiplied. So what this means, 2 with an exponent of 3 means that I have 2 multiplied by itself 3 times. So I have 3 2s being multiplied together. So this is called power form, and the way we read this, power form. We read this as 2 to the power of 3. We're also, for reasons I'm going to explain in a little bit here, called this thing 2 cubed. Sometimes we leave off the power of portion. We just say 2 to the 3. There's all the ways that we read that. This means 2 times 2 times 2. This form has a name. Finish, Garrett? Nice. Throw it in the bin, and then you've got the handout for today's lesson on your desk. We call this repeated multiplication. I'm going to grab a new color here. If we repeatedly multiply 2, 2 times 2 is? Times 2 again is 8. And so then we say that this is evaluated, is the language that we talk about here, evaluated or standard form. So for some of you, yeah, this might be brand new notation. If Ethan is to be believed, his middle school teacher was keeping secrets from him. I will do attendance at the end of class. I'll do attendance at the end of the block. So, the exponent, we've already said it, but we'll write in here again. The exponent represents how many times the base is repeatedly multiplied. So 2 cubed, oh, there's some typos in here, I apologize. So 2 cubed is 2 times 2 times 2. Get rid of that equal sign. Shouldn't be there. 5 squared means 5 times 5. Get rid of that equal sign. But we can also go the other way. Maybe I give you, Zach, you with me? Okay. Maybe I give you the repeated multiplication. Okay, I've got 3 and I've got 3 multiplied 1, 2, 3, 4 times. So how could I take this repeated multiplication and rewrite it in power form? What is the thing that I'm repeating? 3. So that's my base. How many times? There's the exponent. You just need a new calculator? Yeah, you're looking for the Casios? That's not going to be, oh, that'll be a Casio, yeah. So scribble out that equal sign again. I didn't mean to put it there. What's this one going to be? Yeah, it's a Casio. Okay, grab one of the pink Casios then. Garrett. 7 cubed, or 7 to the power of 3, you betcha. And we're going to get rid of that equal sign there. Now, every one of you needs to grab a calculator. Or be sitting next to someone with a calculator. Oh, hey, that's what Sahil was looking for. You guys took my Casios. Grab a calculator. I'm going to teach you now how to use your calculators, for those of you who've never seen this stuff before, for notation like this. Okay, so here we go. This is my old Casio. It's a little different than some of the newer Casios. So I say it here, every calculator works a little differently. You need to know how yours works, or the one that you borrow from me. If you're not in the habit of borrowing the same one every time, I would encourage you to get into that habit. Continue to try, if you're going to take a calculator from me, take one that you're comfortable using every time. So I'll show you how they all work. There's a couple different kinds of buttons that you're looking at. One of them is going to be an X to the Y button. Take a look, see if your calculator has that button. It might not have that button, it might have this button instead, a little triangle up. You're looking for either of these two buttons. The Casios don't have either of those buttons. On the Casio, this is the button that you're looking for. There's going to be an X, and then there's going to be a box. This is what the Casios have, if I'm not mistaken. Find out which button your calculator has.
So I'm not going to press the X and then the 2 and pressing the up one?
The X and then the Y.
No, but mine has X.
Yeah, but does it have XY? Does it have a little arrow? So that's the button we're going to use. Okay, so how this works is, for example, if I want to do 5 cubed, we're going to push on all of the, as long as you've got one of my good calculators, you're going to push the button 5, and then you're going to push whichever one of these buttons comes next. You're only going to have one of these options, but that's the button you're going to push. So that one, don't worry about the 2. That's the button I want you to use. Yeah, the arrow button. One of these 3 buttons. You're going to push it, and then what happens next will change depending on the calculator you have. So you're playing with a Casio, so you have a little button, you have a little box that opened up next to the 5. regardless of what happens next, you pushed your 5, you pushed the correct button, and then you're going to put a 3 there. And then I want you to hit the equals button. And all of you need to get 125.
Yes.
Then you made several different mistakes. Bring it here. It's not possible.
I got one.
Can we watch that movie now?
Ooh, they do different things. How is that possible? Okay, so here's what we're going to do. We're going to go shift blam, and we're going to go all, yes, and then we're going to go, that's the AC key, and then we're going to go shift bam, and then we're going to go bam, and then we're going to go yes, and then we're going to go that one. And now boom, they do the same thing.
I don't know what's wrong.
Okay, so your button is that button right there. So if you're looking with the TI, you're going to push 5, and then you're going to push the up arrow button, and then you're going to push a 3. Equals. There you go. So no calculator is going to have all 3 of these buttons, because these 3 buttons all do the same thing. The TIs have this button. The Casios have this button, I believe. The newest Casios, the pink Casios, have this button. The Sharp calculators and the Staples calculator, I think, have this button.
No, mine has the.
Yours is this one? The Staples one is the up arrow? Okay. And I think it was Jovan. Someone was saying, but yes, there is a squared button. That is true, useful for squaring things. But if we need to ever use any other exponent, it's these buttons are the ones that you need to be comfortable with. Yes, Ethan.
I don't know how to do it.
What calculator did you grab?
Casio.
Okay, so you push number 5.
Yeah, I don't see that.
Push the 5. And now look for one of these 3 buttons. On your Casio, because it's not the pink Casio, I think, what are you, just 5 once.
I know, but like, being weird to me. Okay, yeah, now what?
And now you're looking for either, I'm pretty sure it's going to be this button here, X to the Y, or the up arrow button if you've got one. And then push 3, and then push equals, and your calculator should spit out 125. Cool? Love it. So if yours calculator is not one of these 3, let me know. So I want you guys to crank out these 4 crank out these 4 for me right now. What do you get?
625.
Okay.
64. 13. 10,000. Like 1, 0, 0.
So 100,000. Okay. Make sure that you can get all 4 of those values. I'm not looking for the right answer. I am looking for the right answer. The point is, I wasn't looking for one of you to answer all 4 of these. I want all of you to make sure that all of your calculators can get these values. That is the point of these 4. That makes sense. All of them? Good. When you're ready, flip the page.
Can we watch that movie now?
I will let you know when is movie time.
Watch Cinderella.
If we're watching a movie in math class, it's a math movie.
Damn.
What kind of math movie would there be?
Hidden Figures is a really good one. For those of you who may have never seen Hidden Figures, it's about a bunch of African-American women who were marginalized back during the American space race. So as you know, the United States went through segregation. There were this group of women, they were all black, and they were all working for NASA. They are responsible. Without them, NASA doesn't put a bunch of white dudes on the moon. And so it's about their story. It's a very cool movie.
Pretty sure I saw that one, but I always saw the tail end of it.
That's or A Beautiful Mind, also a great movie about a mathematician. I usually watch that one in my psychology class. So when you're ready, flip the page. Here we go. We're going to take a look at negative exponents, or no, negative bases rather. Okay, so the notation here is picky and finicky, which is why we're going to do what I'm about to do here. And so for those of you who don't like picky, finicky notation, I apologize in advance. because I know some of you are going to be irritated by this. But that's okay. It's important. It's like learning grammar. You need it. It's math grammar. So I've got 4 numbers here. I've got -2 cubed. This one has brackets. I've got -2 in brackets cubed. I've got -5 no brackets squared, and then I've got -5 in brackets with a squared on the outside. Now the reason I've got these 4 here is because they behave slightly differently, and we're going to look at how each one works. This one here, I've got -2 cubed. Now when I've got notation that looks like this, a minus sign out front of a number like this is the same as this. I'm going to draw a little arrow up here, and I want you guys to write with me. When I've got negative and then 2 cubed, there's no brackets. This is how it's written. What this means is I have a -1 times 2 cubed. That's what that means.
Let's rewind you out.
Nope, we will.
Yeah.
But you gotta let me finish this first. Okay? A minus sign out front of a number like this means I've got -1 times and then the base to the exponent. That's what this means. What do you mean? Sorry, who said how? How? How is that true? This is the hard part. It just is. That is what this means. This one right here, I'll separate it out here for you, and then we'll go back and fill in these boxes after. When I've got brackets around here, the negative, I'll write it out like this, the -1 times happens on the inside. Perhaps you've never been told this, and that's fine, but this is what it means to put a negative sign in front of a number. It means you're multiplying it by -1. And you might think, well, why does that matter? Why do I care? It matters now with exponents because of a little 6-letter curse word that I taught you that we went over first chapter. 6-letter curse word starts with B, is BEDMAS. It's like everyone's favorite math F word, fractions, right? We have words, buzzwords in math that trigger up uncomfortable feelings in us. And BEDMAS is one of them. So BEDMAS says brackets, exponents, division, multiplication, addition, subtraction. We haven't been doing any of the exponent stuff, but when we've written something like this, Danny, stay with me here. When we've got something written like this, it means this. And when I'm using BEDMAS, it means that what has to happen here first? Brackets, then exponents. That 3 is an exponent. Then division, multiplication. So what this means, when I have -2 cubed with no brackets, it means that my base is, well, it's -1 times this exponent is only on what comes right next to it. It's only on the 2. So this is going to be times 2 times 2 times 2. So that base is 2, the exponent is 3, and that minus sign there becomes a -1 times 2 times 2 times 2. The notation here is picky. If I were to then go and evaluate this thing, 2 times 2 times 2 is 8, and that -1 multiplies up front, giving you -8. Yes, absolutely. How does this second one behave? Well, when the negative is included inside a set of brackets, it becomes -1 times 2. BEDMAS says I do the math inside the brackets first, and then I bring the exponent on afterwards. Are you done or you have a question? Sweet, come on and hand it in. Jared, you good? Okay. Where are your guys' calculators? Oh, okay. Yeah, pen that in and bring all your stuff back in. So when it's inside there, it means I'm going to do the multiplication first, and then we're going to apply the exponent. So this is going to become -2 in brackets again, cubed, and then this is the thing, the -2 is the thing I'm going to repeatedly multiply. -2 times -2 times -2. So -2 is the base. We're very dramatic with our yawning there, Ethan. The exponent is still 3. I need you to stick with me, though. This is the thing that we're going to repeatedly multiply. And what now is this thing going to be in standard form? It's going to be -8 again, because I've got 2 negatives is going to make a positive, and then that third negative is going to make it negative again. So you might be asking yourself, why the heck do we care? The answer is the same both times, and to that I'm going to say, well, let's take a look at the next two and see what happens. If I've got -5 squared, taking a look at what we did up here, what's the base going to be on this guy? When there's no brackets, it's going to be 5, Hassan, you betcha. Because when there's no brackets, that negative is just going to jump out front like a -1, and we're going to multiply that by whatever's happening here. What's the exponent on this thing? It's a 2, thank you. No, the base is 5, the exponent's a 2. So that means the minus sign becomes a -1 multiplied out front. The 5 squared is going to become a 5 times a 5 here. And Sabrina, I tossed the booklet that we're working on onto that desk right there next to Cheyenne. And it'll be -25 again. You betcha. Jared, you've got a copy as well. So then let's look at this last one. Can you just hang on here, Ethan? I know you are, but every time you say something and I have to interrupt, it takes more time. It means less time for Mindtrap, attendance questions, and maybe even that movie you want to watch. I'm almost done. Just let me finish. So then this last piece here, thank you, appreciate it, is -5 in brackets squared. If we look at what happened here, when you have brackets, the negative is included as part of the base. So this thing's going to be -5 is the new base. Squaring this thing means what am I going to do for repeated or for expanded form?
-5 times 5x.
No, it's -5 times 5.
Yeah.
I need negatives on both of them. -5 times -5 is?
25.
Positive 25, you betcha. So the brackets around here are important about half the time. When are the brackets really important? When the powers are, when there's no math inside of it, or when the exponents are? The exponents are not going to be negative this year. That's next year. What's the difference between the number 3 and the number 2? What kind of number is 3? It is odd, Garrett. Thank you. When the exponent is odd, the bracket placement doesn't change the final result. But when the exponent is even, these two sets of notation give you different results. With the brackets, it's positive. Without the brackets, it's still negative. So again, like I said, about half the time, about half the numbers are even.
Because when you times the negative by a negative,
Correct. And when you do that an even number of times, it stays positive. If you do it an odd number of times, you're always going to have a 1 left over negative. So when the negative sign is outside the bracket, the negative was not repeated. When the negative is inside the bracket, the negative is part of the base and is repeated. And when you have an even number of negatives, the answer is positive. When you have an odd number of negatives, the result is negative. So the notation matters. It's picky. And for those of, it's not just, it's all of my students, grade 9 and 11. If you're not careful about how you notate things, stuff is going to get lost. Yes, Ethan. Everything I've been doing is notation.
Actually,
This is all notation. Me being picky about where brackets go is what I mean by notation. It's like in English where they're like commas go here and apostrophes go here. It's notation, but in English. This is notation, but in math. Okay. So we're going to do fractions and I'm done. The same basic principles apply if that number is a fraction. Nothing changes. If I have a half and I'm cubing it, My base is 1/2. So what I'm going to do then is I'm just going to multiply that fraction by itself this many times. So the half is the base, and I'm going to multiply a half by a half by a half. Now this isn't so bad because it's really nice to multiply fractions. Adding and subtracting fractions is where things suck. Multiplying fractions is where things are beautiful. How do we multiply fractions? Garrett.
On the top and bottom.
We just march across the top and then you march across the bottom. So 1 times 1 is? Times 1 again is? Beautiful. I had some of my other math students tell me it was 3. 2 times 2 is? Times 2 is? And we're done.
Finally, we're doing it.
Fine, it's gonna be easy.
Okay, let's go to this one. 2/3 to the 4. My base is? 2 over 3. My exponent is? So that just means I'm going to take 2/3, I'm going to multiply it by itself that many times. 2 over 3 times 2 over 3 times 2 over 3 times 2 over 3. And we just march across the top and we march across the bottom.
Do you see it?
2 times 2 is? Times 2 is 8. Yes, someone said 16. 4 twos is 16, or 4 twos multiplied together is 16. And then this is where this becomes a little bit more challenging. An easy way to do this is to group them into pairs, because 3 times 3 is? So these two are going to give you 9, these two are going to give you 9, and then 9 times 9 is? They've spent so much time working with their multiplication tables, it just sticks into their brain. It's what repetition will do to you. And we're done. Last one. Now the negative is part of the inside of the bracket, so it's included as part of the base. So I'm going to write this one below this line because I don't have a lot of room above. I'm going to write it as negative 1 over 3 times negative 1 over 3 times negative 1 over 3. Because the negative sign is inside the bracket, it needs to be part of the repeated multiplication, and there's 3 of them because that's what the exponent is. So the final result here is going to be positive or negative. How many negatives do I have? I have an odd number of negatives, so it's got to be negative. Because 2 negatives makes it positive, and the third negative makes it negative again. And then 3 times 3 is?
27.
Is 9, and then 9 times 3 is? 27. So 27 is going to be in the denominator. 1 times 1 times 1 is? 1. And you're done. Okay, what I want you to do is I want you to flip the page. This is your homework. You can use your calculators to give you standard form. And I'm done. Well, you don't have to have homework unless, you don't finish it in the next 15 minutes.
What if I don't do it at home?
Well, I feel like there's a conversation in your future that's going to encourage you to do some work at home. Well, my email inbox says otherwise. Feel like there might be a conversation in your near future about, that. Or in your recent past. The conversation may have happened already. You may. Okay. This is what I want you guys to do. On your market take giver. Garrett, why are you packing up? Why? No, I want you to do it now. Don't waste time. I want you to start it now in class. No packing up. I'll tell you when to pack up. Do some work for me, and I'll give you a mind trap. No mind trap without any work.
They're like engaged and stuff.
What do you mean? Yeah, for a Friday, for a Thursday morning of a short block of a long weekend. You bet. Okay. With all your stuff. Okay. Yeah, put your name on the board. Okay. My C block math class. Jason was away. Angela was here. Krishan was here. Ruben was here. The Haydens were here. Oliver and Jeff Neat were here. Gabe's away. Colton. Yes.